Physics problem related to Snell's law. A light ray approaches a glass block of 30 degrees to the normal. The refractive indices of air and glass are 1 and 1.5 respectively. At what angle will the light be refracted? So to answer this problem, first we need to identify correctly the given variables. For the angle of incidence, we have 30 degrees. For the refractive index of air, we have 1. For the refractive index of glass, we have 1.5. Now, we are asked to determine the angle of refraction in the problem. Now, to clearly understand the problem, we need to draw and illustrate the situation. Okay, so we have here the incoming incident where there is a 30 degrees angle of incidence. Okay, and then what we are asked is to determine the angle of refraction. So first we have air, and then the second medium we have the glass. For the equation, we can make use of the Snell's law, where n1 times sine I is equal to n2 times sine r, where n is the refractive index, and for the I, this is the angle of incident, and r will be the angle of refraction. So, our next step is to rearrange the equation so we have the final formula to get the angle of refraction. Rearranging the equation, we have sine r is equal to n1 times sine I divided by n2. So the next step is to substitute the given variables. For n1, which is the refractive index of air, we have 1. For I, we have the angle of incidence of 30 degrees. And for N2, which is the refractive index of glass, we have 1.5. So our next step is to use our calculator and perform the operation. 1 times sine 30 divided by 1.5 will result to 0.3333, and the next step is to get the inverse of 0.3333. Using the formula, our final answer will be 19.5 degrees. So the angle of refraction in the problem is equivalent to 19.50 degrees.